All right, today we are going to look at an introduction to some basic statistics, some of which you already know, but I want you to know how you can find these things on your graphing calculator. Of course, that part won't actually help you with the STAR test, but it will help you for the future to be able to know how to find these different things using your graphing calculator. So if you don't already have your graphing calculator out, you probably should get it out because we're going to be using it, as you can see by the screenshots and directions. All right, so, and there's my graphing calculator. I've got all the definitions up here. Most of them you already know or are pretty self-explanatory just by reading. So I'm not going to go through and read all of these to you. You can go through and read them. I do want to point out some of the symbols here. The mean, which we all know what the mean is and how to calculate it, but these two symbols both are symbols for mean. The first one is actually read X bar, and the second one is mu. It's a Greek letter, the Greek letter mu. Both mu and X bar are symbols for mean, so if you ever see that on an ACT or Accuplacer or STAR test, anything like that, that's what those mean. It's asking you to find the mean of the data. Also, the other symbol that we have here, this is a lowercase sigma, and that's the symbol that is used to represent standard deviation. And these are definitely universal things across, countries in mathematics, that X bar, mu, and sigma are used to represent the mean and then the standard deviation respectfully. So again, please read through these definitions. If you need to pause the video, you can do that if you want to, or you can do it later, but make sure you know the definitions for each of those. So in order to find these basic statistics on our calculator, I've got the screenshots and the directions typed out for you, but first thing you're going to do is enter the data that you're trying to find the measures for. And similar to when we did scatter plots, we're going to go to Stat and Edit and enter our data there. So we've used this part before, so I'm going to go to Stat. And when I press Stat, this is the menu I get, so I'm going to choose Edit. And my lists are clear right now, so I don't need to clear any. If yours are not, remember that you can clear lists by pressing Stat Choice 4. So if your lists aren't clear, you can press Stat Choice 4, and then you just type in the names of the lists that you want to clear. So if I wanted to clear L1 and L2, after it comes up with clear list, I would press second L1, which is 1, and then the comma, and then second, and then L2, and then I would press enter and it would clear them. Obviously mine were already done, but just to review that from earlier. So we're going to enter our data pressing enter between each value. So we are going to do all of this for example 1 here. So we've got some data that is representing boys basketball scores. So these must have been the scores for one team in different games. So we are going to enter these pieces of data just as they appear. So I go back to Stat, choose Edit, and I'm going to enter them in my list 1. So I just hit 43, enter, 46, enter. And then 47 appears twice. Make sure you enter it twice. That does matter. Then I've got 48, 50, 51, 51, 53. You guys are probably faster than me at this, but I figure if I can get it done, then you can get it done as you're following along. So I've got the two 55s, so I need a 57, a 58, and 3 59s next. So 57, 58, and 3 59s. Then I've got 61, 69, 70. It's a big jump there. And then 71, 75, 76. Now, just like we talked about when we used scatter plots, it's really important that you double check your data, because if your data is wrong in your calculator, then obviously you're not going to get the right answers, and there's not a lot I can do for you in the way of partial credit, because really we're just writing down the answers. So I kind of am going to work backward and check. So I've got 76, 75, 71, 70, 69, 61, 59, 59, 59, 1, 2, 3, 58, 57. So need to scroll up here. Okay, so the 57 I checked. Then I've got two 55s, yes, 53, two 51s, 50, 48, two 47s, a 46, and a 43. So I've double checked my data after I entered it. I'm good to go. So now, going back to the steps, we entered our data. So now step 2, I'm going to hit second quit because that exits out of the data entry. Now to calculate the stats, I press stat and then I scroll right to calculate. Now we've been in this menu before when we learned to do linear and quadratic regression. Now we're going to choose choice 1. That stands for one variable statistics. So I'm going to hit 1 or press enter to choose it. And then you have to specify the list. Now, if you have an older version of the calculator, you may not get this screen. It might just say one var stats, on the home screen. If that's the case, the default list is list 1. So if you're using list 1, you can just press enter on the old calculator. But if you're using any other list, you have to name it first. So if I was using list 2, I would press second 2, so on and so forth. Obviously, I am using list 1, so I'm going to put it back. You do not need to put anything into the frequency list here. So just scroll down to calculate, and the older version, you just press enter. And then you should see a screen that looks something like this. These screenshots were obviously not specific to this example. This was just showing you what it should look like. So I have those one variable statistics up there. Now, this does no good to have the calculator help us do this if we don't know what it means. So it's very, very important that we can interpret this. So when I'm looking at this, X bar is the sample mean. So I'm going to have you guys write that here in your notes. Next to X bar, this is going to be the sample mean. The next one we don't really care about so much. In fact, the next item that we really care about are these ones. And so SX stands for the sample standard deviation. And then sigma X stands for the population standard deviation. So do you just want the standard deviation of this sample, or do you want to apply this standard deviation to an entire population, to all boys basketball scores, for instance? If you scroll down, an N tells you the number of entries that you had. So that's another way just to check to see if you accidentally messed up when you entered the data, because if you count your data pieces and it doesn't match the number here, so if there weren't 22 scores, then we know we did something wrong. If I keep scrolling down, I can see more. That's why there was an arrow there. And this all the way at the bottom should be max X. So these ones are pretty self-explanatory. Min X is the minimum value. Q1 is the lower quartile, which is the median of the lower half. MED is the median. Q3 is the upper quartile, which is the median of the upper half. You have probably found these items before. I know in junior high math, box and whisker plots usually get introduced, and you use the lower quartile and upper quartiles for that. Obviously, max X is the maximum value, the highest value. So, based on the information that we now see in our calculator, I should be able to answer the questions for example 1. So the mean, if I look here, my mean, sample mean, is 50, oops, I forgot to scroll back up. It won't let me scroll back up. There we go. Got it. I've got 57.27 repeating, so we'll round to the nearest tenth here. So we'll say that our mean is 57.3. The median was down a little lower. There it is. It's 56. The mode has to be found separately. You can see that I said that in the direction. So mode is the number that appears most often according to our definitions. So in this case, the mode is 59. It appears 3 times, which is more than anything else. Remember from junior high math that you can have data that doesn't have a mode. If everything appears equal number of times, you would write none. You could also have multiple modes. So if 59 only had 2 appearances, then 59, 55, and 51 and 57 would all be modes. The range you have to find separately by taking the max value minus the min. So max minus min, which, when we look back at our calculator, the max was 76, the min was 43. So 76 minus 43, which gives us a range of 33. The standard deviation here, it depends on what we're using it for, which standard deviation we choose. If all we're doing is for the data below and we're not trying to apply it to a bigger study, then all we would need is the sample. So the sample mean is the SX that we labeled, which would be 9.7. If we're trying to apply it to a larger group, like if we were trying to take these boys basketball scores and make assumptions about all boys basketball scores, then we would use the population, which was listed at 9.4. So this is our standard deviations. This means how far does it go from my mean? So the mean is 57.3. How far does it deviate from that? So min and max I kind of already did here with the range. The minimum was 43. The max I know was 76. The median I already listed once. I'm listing it again because I need them all in a row. The lower quartile is 50, as I can see on the calculator, and 61 for the upper. So I'm just going to review a box and whisker plot because they're good things to know how to read. They tell us a lot about data in little spaces. So when I draw a box and whisker plot, I make my whiskers from my minimum and my maximum values. So I need to pick a scale here. So we always go a little below and a little above what we need. So here I'm going to start at 40 and I'm going to go up to 80. And I can do that if I count by 4s. I'm only going to label every other, but I am counting by 4s here. That would be 72. You have to have a scale or a box and whisker plot is meaningless. So 43 is my min, so the middle here would be 44, so it's a little below that. I always do mine right above the scale. You can do it below also, it doesn't really matter. My max is 76. So 76 is actually right on this guy. So I'll put it right there. Then I make my box. My box comes from the median. Oops, I didn't draw that right. From the median, the lower quartile, and the upper quartile. So 50 would be right here, the lowest part of my box. The median is 56, so exactly there. And the upper quartile is 61. Well, this one would be 60, so it's a little above that. And I draw my box. Then I make my whiskers by connecting the box to the min and the max. You should always label the actual values themselves because if they're not on the exact coordinate, it's important that people reading the graph know what the actual value is. What this tells us is that 25% of the scores are between 43 and 50. Another 25% are between 50 and 56, between 56 and 61, and between 61 and 76. So notice this range is a lot wider. This one a lot smaller, but they still hold the same percentage of the data. So 25% of the data occurred in this span of 5 scores, whereas this 25% is way more spread out, having a range of 15. So it tells us how the data is clustered, essentially, and where the middle of the data is. So that's one thing that you'll be asked to do in your homework. The other thing that we're going to do, part 2, is normal distributions. So this is something that I've seen on the STAR test standards as something that a lot of you are ready to learn. So if you happen to get a question on this, normal distributions, there's a lot of data that we would consider normally distributed. So one thing is test scores are often based on a normal distribution. Here it tells you what a normal curve is. This is a picture of the normal curve. It's symmetrical and bell-shaped. 68% of the data is within 1 standard deviation of the mean. So here's our mean. So that means that 68% of the data is within 1 standard deviation. So x minus a standard deviation and x plus a standard deviation, 68%, which is why each of these areas is labeled 0.34, because together that makes 0.68, which is 68% of the total because they add up to 1. 95% of the data falls within 2 standard deviations. So that means from here to here. And then 99.7% of the data falls between these marks, which is 3 standard deviations. So here's how we use a normal curve. It says in 2015, college-bound seniors had a mean ACT score of 22 with a standard deviation of 5. We use it to find probability. So we want to know the probability that a randomly selected college-bound senior scored between 12 and 22. So the first thing that I always do is I draw myself a normal curve and I label based on the information that they give me. So the center is always your mean. You can see that here. So my mean here should be labeled 22 because that's what they told me. The standard deviation is 5, so the next little mark should be 5 away from the mean. Obviously on the left side it should be 5 below and 5 above on the other side. So 5 less than 22 is 17, 5 more than 22 is 27. Then I do 2 standard deviations. So 5 less than 17 is 12, 5 more than 17 is 32. Then 1 more standard deviation would complete the 3 standard deviations. So 5 less is a 7. 5 more here would be a 37, but that's not possible, so we'll just list 36 because obviously 36 is the maximum. All right, so between 12 and 22, all I do is I kind of look at the area that is between those values. So 12 and 22 is from here to here. And then all I have to do is look at these numbers on the normal curve. So I know that this one right here is 0.34. And the one next to it is 0.135. So the probability of falling between these two would be 0.34 plus 0.135, which gives us 0.475. If it asks for probability, probability should always be given as a value between 0 and 1. What it means is there's a 47.5% chance of a score falling in that range. So less than 50-50. B says at most 32. So that means 32 or less. So let me pull a different color here. Let's try green. 32 or less would be everything down here. Now, we could get that answer by adding up all the individual pieces. However, it would be best to add only what falls beyond the 32. So 1 standard deviation was here, 32 was 2 standard deviations. So the only things that are above 32 are these right here. So it's all but this part. So first I need to find that part, which is 0.0235 plus 0.0015, which gives me 0.025. Now, that's not the probability of scoring at most 32. The probability of scoring at most 32 is all but that. So 1 is the whole, so it's 1 minus the 0.025, which means 0.975. So 97.5% of people score a 32 or less, which is most people. When you score better than a 32, that's obviously a really good score, puts you in a very small percentage of people. So the probability is 0.975. All right, example 3. Light bulb life expectancy, also normally distributed with a mean of 1,000 hours and a standard deviation of 50 hours. So again, my recommendation is to always draw and label the curve first. So mean of 1,000, I label that. Then standard deviation is 50, so 1 standard deviation away should be 950 and 1,050. 2 standard deviations away should be 900 and 1,100, and 3 standard deviations would be 850 and 1,150. And that gives me all the room for all of my little sections that I have in the normal curve. So part A says what percent of bulbs will last for 1,000 hours or more? So 1,000 or more means this. So the mean or bigger. So again, you can add all these pieces up if you want, these 4 little areas. 0.34 plus 0.135 plus 0.0235 plus 0.0015. However, you should know that that's half, right? It's half the curve. So on this one, I'm okay with you just writing the answer because it's pretty easy to see that it's 50%. And again, the reason why I didn't use a decimal here is because this question specifically said what percent of bulbs. Now B says what is the probability? So this one will not be a percent. What is the probability that a randomly chosen bulb will burn out in 900 hours or less? So 900 hours or less, that would be down here. So it's just those 2 little areas. So 0.0015 is the leftmost, plus the next one, which is 0.235. These are the same things that we added together here. So hopefully it still gives us 0.025. And that is our probability. So it's good if the mean is 1,000 that very few of them burn out in 900 hours or fewer. C, what is the probability that a randomly chosen light bulb will last between 850 and 1,050? So 850 and 1,050 is this area right here. I'm trying to use different colors. So this. So what I would do is, I know these are both 0.34, so that gives me 0.68, and then I'm going to add, so I did this part, I did this part, now I need this one, which is 0.135, and this one here, which is 0.0235. So I add all three of those up, I get 0.8385. That is the probability that it'll last between 850 and 1,050 hours. Last one, what is the probability that 3 randomly chosen bulbs all last between 850 and 1,050 hours? Now, this, it's the same area, right? 850 to 1,050 is in here. But what's different here is that they're asking about 3 randomly chosen bulbs. This is what we call in statistics a compound event. And when you have a compound event, because you're doing the act 3 times, you're choosing a light bulb 3 different times. So the event originally has a probability of 83.85% or 0.8385. When you have to have that happen 3 times, then what we have to do is we multiply the individual probabilities together. So the probability that the first light bulb lasts that long is 0.8385. The probability that the second light bulb lasts that long is the same. It's also 0.8385. The third light bulb still has the same probability, and so I multiply them all together, which gives me 0.5895. Now, the reason I wrote it like this is because sometimes you have compound events that have separate probabilities. So the probability of the first thing happening is 0.5, but the probability of the second is 0.7. You would still multiply them together even though they weren't the same. Here, because it's the same probability each time, you don't have to write it like this. You can certainly write it as 0.8385 to the third power, and that would be perfectly fine. I just wrote it like this so that I could talk about the situation where the events were different. All right, so that gives you kind of a brief introduction to statistics. Maybe it makes you want to sign up for that stats course for next year, or maybe not. But you have your worksheet for homework, should be very similar to this. And that's all for today.